Hello everyone and welcome. Today's presentation is brought to you by Science Visualized. And today we're going to look at carboxylic acid derivatives. So what are carboxylic acids? Carboxylic acids contain alkyl group, a carbonyl, and an OH connected to that carbonyl. So that's a carboxylic acid. Carboxylic acid derivatives, on the other hand, also contain an alkyl group, a carbonyl, but now instead of the OH, you have a Y group, where the Y group will be different kind of substituents. So for example, if Y equals to OCH3, then now you end up with this derivative, R carbonyl OCH3, and that is called an ester. If Y equals to NH2, so an amine, you end up with this carboxylic acid derivative, and that's called an amide. If Y equals to a halogen, which will be chlorine, bromine, iodine, or fluorine, then you end up with this carboxylic acid derivative, which is called an acid chloride. The general family name is acid halide. You can also have a situation where Y equals to a carboxylate. That means it's an OC double bond O and then another alkyl group, and I'll put that mark there to show that it doesn't have to be like it doesn't have to be the same as the other R group. Then now you end up with this carboxylic acid derivative, and then now you include that substituent OC double bond O R, and that's called acid anhydride. The most reactive carboxylic acid derivative is acid halide. I'll rank that as number 1, followed by acid anhydride. I'll rank that as number 2. Then followed by esters. I'll rank that as number 3. And then the least reactive is going to be the amide. That means it's very easy to convert acid halide into any of the other derivatives by just reacting with the corresponding nucleophile. So the nucleophile will come here and displace the chlorine. So you end up having that double bond move to that oxygen. Then you end up with RCO minus, and now you have the nucleophile, and then you still have the acid halide. And then the next step, the minus charge, that's 2 electrons, will come back to form a double bond, and then you kick out the chlorine, and you end up with RC double bond O Nu, and you easily replace the chloride or the halogen with a nucleophile. The same reaction can be done with esters and acid anhydrides, and we're going to be looking at some of those reactions. Next, we look at the reactions of carboxylic acid derivatives. And again, we say the general formula for carboxylic acid derivative is alkyl group, carbonyl, and then Y, where Y will be different groups depending on which type of carboxylic acid derivative you're talking about. So I just recently discussed the general reaction mechanism with a nucleophile. So when you add a nucleophile, use a different color for the nucleophile will displace the leaving group. So the end result will be RC double bond O, but now the Y has been replaced by the nucleophile. So that's called nucleophilic substitution. Now let's look at a specific example. If you use RMGX, that's a Grignard reagent, we know that that gives an R minus nucleophile. And now let's use a real example. Let's say we use this carboxylic acid derivative plus CH3 MgCl. That's a type of Grignard reagent. It has alkyl group, magnesium, and chlorine, and that gives a CH3 minus nucleophile. So the CH3 minus nucleophile has high electron density, and therefore it will attack the carbonyl, which is more electrophilic. That means it will accept electron pair, and then this oxygen already has 2 electron pairs, and then the double bond will move to the oxygen, giving another electron pair, and therefore you end up with 3. And then you have the 2 electron pairs that came from the double bond, and you still have the other original 2 electron pairs, and therefore you have a minus charge on that oxygen, minus formal charge. And this intermediate is called an alkoxide or a tetrahedral intermediate. The last step will be this electron pair of minus charge will come back to form a double bond, and then at the same time you kick out the bromine, which leaves us a Br minus, and therefore you end up with this as the product. And now you have a double bond there, and the bromine has left as a Br minus. You have the nucleophile from the Grignard, and then plus Br minus. And you see that this product here is the same is in this form here, where the nucleophile has replaced the leaving group. So the leaving group was Br minus, the nucleophile was CH3 minus, and now you end up with the nucleophile at that position. Another reaction is with reducing agents, and reducing agents give H minus nucleophile. And now that has high electron density, and that attacks that carbonyl carbon. The electrons flow to the oxygen. And now you end up with a tetrahedral intermediate with a minus charge on oxygen. You still have the chlorine connected there, but now you have the nucleophile at that position. And then the next step will be the minus charge coming back to form a double bond and kicking out the chlorine, which will give you the product. Now that becomes a double bond, and you have the nucleophile, which was the hydride or hydrogen at that position, plus the chlorine minus. If you use a weak reducing agent like dibal, also called dibal H or dibal, and that's diisobutyl aluminum hydride. If you use a stronger reducing agent like lithium aluminum hydride, also called LAH, or boron BH3 or B2H6, or sodium borohydride, you will end up adding the H minus nucleophile 2 times. So that means you end up with an aldehyde, but then that reacts again with another H minus nucleophile. So that H minus attacks that carbonyl, and then you repeat the same process. You still have the original hydrogen from the first step, and then now the second hydrogen, you end up with an alkoxide intermediate, which is then quenched by addition of water or a proton source, say an acid, and that will protonate this O minus, and you end up with an alcohol at that position. Therefore, if you use a strong reducing agent, it will reduce a carboxylic acid derivative all the way to alcohol. If you use a mild reducing agent like dibal, the carboxylic acid derivative will be reduced to an aldehyde. Thank you very much. Please support the channel by subscribing.